Now, Mr. Sams, now that we've learned about kind of where the electrons are kind of in space.
And aren't.
Yeah. We want to actually kind of give an address to them. So that's the concept of electron configurations.
Electron addresses.
Yeah, it's like an address.
Yeah, that's cool. I like that.
I like this. The electron addresses that we want to talk about today. So electron configurations follow a couple of rules, or principles technically. The first one's called the Aufbau principle. Probably going to pause the podcast right here, and this is it. They fill orbitals starting at the lowest available levels before filling higher levels.
Yes, pause, write that down real quick.
And what that basically means, folks, is that if you've got a level, this is an energy level, and then there's another energy, another energy, another energy. It starts with the bottom energy level first, and they actually use arrows, and arrows indicate an electron, and we'll talk a little bit later about why they're arrows. Okay, the second thing is called the Pauli exclusion principle. And the last one is Hund's rule, and I'll have slides for each of those. So in the Pauli exclusion principle, the electrons can only be in one place at a time. So they can't be in two places.
Nope.
Only one.
Can have one spot. Now they can move to a different spot, but they can only be in one place at a time.
Yeah, and we'll illustrate that.
Yep.
And the last one is called Hund's rule, and that says that you fill orbitals of equal energy first before pairing up. So if I've got three orbitals, now we learned about an orbital, and actually orbital notation, we use these things called, they're boxes.
Yeah.
And actually it would be more like this. So if I've got three orbitals of equal level, okay, those are boxes, and those would be like p orbitals that we talked about in the previous podcast. Remember the p orbitals? And there's three different p orbitals. If I have, say, 4 electrons to put in this box, I would put one here, and one here. I don't pair them up first. They're equal energy. Well, I have to pair the fourth one up, and this is how you would do that.
And show them how you wouldn't do that.
Yeah, what I wouldn't do, good call, Mr. Sams. What I wouldn't do is I wouldn't do 1, 2, 3, 4. I wouldn't do that because
you'll never have a paired up set with an empty orbital in the same energy level. And when we start doing more electron configurations, this will make a little more sense. Right now, you may not quite know what these boxes and arrows stand for.
We've got some practice to show you here in a minute. Now, here's the key thing to understand. The thing that people struggle with is how do you fill the orbitals? What's the lowest orbital? Because you've got these energy levels. What's the lowest energy level? The key is that you read the periodic table like a book, left to right, top to bottom. And so here is the periodic table, and we'll kind of go through here. So the first box right here, we start with the very first box. It is 1s, okay? So you fill the 1s first, okay? And then that includes this. The 1s is kind of a weird orbital in that it's both hydrogen, this is hydrogen, and this is helium over here. So you fill them first. That's
and hydrogen and helium, they could really live. I mean, hydrogen could live there, but it could also live kind of over here. Yeah. So, don't worry about
hydrogen. I kind of think as the the orphan child of the periodic table. He's not really an alkali metal, not at all, and but he's not a halogen either. So he's kind of off by himself. So what you're going to do is you draw this blank periodic table, and you're going to fill in with these boxes. The next level is the 2s, as you can see. Remember, we went to a new line. When you get to the end of a line, you went down to the next line, top to bottom. The next level is 2p. All right, and then 3s. And then 3p.
So what you notice here is the s and the p's, the number corresponds to the row number that they're in. In the first row, you have 1s. In the second row, you have 2s, 2p.
So think of this right here, folks, as the s block. This you'll find out in a minute, and it's going to erase here the way I've got this set up, is the d block, and this will be the p block. So just kind of keep going. After you get to 3p, well, you're at the end of a line. Where are you going to go?
Down to 4.
So everybody predict. What do you think that one's going to be? You're right, it's 4s!
Yay, except for those of you who were wrong and didn't say 4s.
Yes, well, this next one's kind of weird. Remember we said this is the D block, and of course you'd say, well, it's 4D. No, it's actually 3D.
3D. So the D's, guys, are one number lower than the row number.
That's right. Yes, indeed. And then this next one continues to follow the same pattern, 4p. We're going to go to the end of the next line, down
here. Take a guess. 5s.
Now, what do you think this one's going to be? Think about it. I hope you're right, it's 4D.
Yep.
And then, of course, here, I think you can see the pattern. That'll be 5p. And I bet you can figure out the next one over here.
I'm going to say 6s.
That's right.
Hey, look at that. But wait. At this point,
things change. Yeah. So we jump down to this line to the 4F. Now this is actually technically in here.
Yeah, F lives there. The reason they don't put it down in there is it doesn't fit on one piece of paper.
That is correct. It doesn't fit on an 8.5 by 11 sheet of paper, so they have to pull it out. So this is not, the 4F is actually 2 levels behind. Kind of weird.
Yep.
And the next one we jump
okay,
back to the D's, and it's 5D. You kind of see the pattern there. And then we go over to 6P, and now we're going to jump down to
7S.
The next level, which is the 7S.
And then 5F.
Then we jump back down to here and see technique, and then we're going to go from here to here and do 6D. Our last one, 6D. And actually, there's a 7P now. There used to be not stuff there, but there is a 7P. And if you really want to know, here is probably an easier one to do. You may even want to just print this and put it in your book.
Yeah, actually. If you're watching this in like QuickTime or something, just hit pause, file, print that out, and stick it in your notebook.
Yep. So that's it. That's the order. So
that's the order that they fill from lowest energy to highest energy.
All right. So now let's just do some examples. That's just the key. Electron configuration practice. So let's do something uber easy, Mr. Sams. Hydrogen. Okay. Now, hydrogen is how many electrons?
1 electron.
Just 1 electron. So if we go back to our table here, what is the lowest energy? Well, at least the top of the page is the 1s right there. So we have to fill the 1s orbital. Now, folks, what you need to do is when you build these, a box counts as an orbital. Okay? Actually, before we do practice, let me do something else here. Before we do this one, we'll just kind of hold this one off for a second. But for s orbitals, they get 1 box. Now, that's an orbital, so that's a particular shape. We happen to know that the S shape is a sphere. But there's 1 box because it can have a maximum of 2 electrons. I know that because right here, there's only 1 or 2 elements, right? Now, for a p orbital, you're going to draw a box that contains 3 boxes. All right?
Okay.
Because if you recall the p orbitals, this is the one that's the px orbital, this is the py, and there's the one that's hard to draw because it's coming out of the page. There's 3 different p orbitals, but they're of equal amounts. And then there's the d orbitals. And I'm not
real quick before we go to d, 3 boxes means we can have 6 electrons.
Yes.
Go back to the periodic table, Mr. Bergman. If you'll notice, there are 6 squares in the p block.
1, 2, 3, 4, 5, 6.
All right, so this should be starting to come together.
And if you look at the D's here...
How many boxes there?
There are 10 boxes, or 10 elements. That means there are going to be 10 electrons, or 5 boxes.
Because each box can have 2 electrons.
3, 4. So there's 5 boxes. And then if you're going to do the F's, you're going to have 7.
Because there's 14 electrons, 7 boxes, 2 electrons per box. That's 14 electrons. And if you look on the periodic table...
1, 3... 5, and 7.
Yay.
You see the pattern there, don't you?
Yes.
So back to hydrogen, Mr. Sams. Hydrogen's got 1 electron.
Yep.
Now, electrons, as you recall, are we're going to write them as an arrow.
Okay.
And so, well, that's it. And we actually would label this 1s. That's the orbital 1s.
Okay.
Okay, because that's from that 1s orbital.
And it looks like it has 1 electron in the 1s.
And there's a second kind of a notation. You would say 1s1.
Right. So
where this 1 is what?
That's how many electrons are in the s orbital.
The number of electrons, and it's in level 1s.
Yep. So real quick, for a clarification, when you're drawing the boxes, those are called orbital diagrams. And then when you write the 1s1, that's called the electron configuration.
That's
correct. When you're asked for this on your test, when it says draw the orbital diagrams, that's the boxes and arrows. When it says electron configuration, that's the 1s2, 2s2, 2p6, all that stuff that you'll see here in a minute.
Good.
Okay, let's do some more.
Well, how about we do lithium next, Mr.
Alrighty.
Sims? So lithium is element number 3. That means there are 3 electrons. So the first orbital box, I'm going to do the orbital diagram first,
by the way,
is
the 3
the
should
1s.
go down the bottom, not at the top.
That's true, actually. Yeah, the 3 should actually be here. You're right. All right, we've got to spin 3 electrons.
Right.
So the first electron is an arrow up and then an arrow down.
Okay. But we still have another electron.
I got another electron.
Yeah, so after 1s is...
1s happens to be 2s. So yeah, we got to the end of a line and we go to 2s orbital, and so we draw 2s. You only get 1 box for the 2s because it's an s orbital,
right.
And we get another arrow.
All right, so there's the 3 electrons.
That's it. So this is the orbital diagram, and then for the electron configuration, you'd say 1s. Now, how many electrons are in here?
2.
2. So you put a 2 squared. That's the number of electrons.
Okay.
And then we also have to identify 2s.
2.
2.
Nope, 1. Sorry.
2s, 1.
Because there's only one
There's
electron
only one
there.
electron in there. Yeah, that's
Sorry
right.
about that.
All right, how about we jump and we do nitrogen?
Perfect.
Nitrogen is element number 7. There are 7 electrons. So the first orbital is labeled the 1s. That's like the lowest level. 2 electrons. All right. Now the second orbital is 2s. Right? Remember that from our diagram. 1s, and then we jump to 2s. And so we're going to put 2 electrons in there because we've got to build up to 7 electrons.
Right, so that's
They've only got 4. And so the next level is we come across the 2s and we see the 2p. Now this is a little different one because there's 6 electrons possible there, right?
So we need 3 boxes.
So we need 3 boxes. So we're going to write 2p, and I'm going to make a bigger box with 3. Now I've already spent 4, so I have 3 more to go. 5, 6, 7.
Now, Mr. Bergman, why did you put 1 in each of those squares?
Well, remember the rule. They have to. You don't double up. You got to. Each of these. They don't like double up. Technically, you know what? Electrons both have the same charge, and if you put them close together, they're going to repel from each other.
Oh, so they like to be alone first, and then if they have to, you go back and double them up.
That's exactly right. So this is the orbital notation, and then for the electron configuration, you'll write 1s2 because there's 2 electrons here. 2s, how many electrons?
2.
2. And then you'll say 2p. Now it's all of them combined. Right. How many in there?
There's 3.
3.
So that's the electron configuration. All right, Mr. Bergman, I'm going to ask you for the pen.
Okay.
I'm going to ask you to relinquish control of the pen.
That's hard for me, Mr. Sanders.
I know, and my handwriting is so horrible. Okay, what I want to do is magnesium. And I'm going to show you an alternate way to do this because I like to work backwards. So magnesium is atomic number 12, so we're dealing with 12 electrons. So let's go back to the periodic table. So what I'm going to do, if you look on a periodic table, you'll find out that magnesium lives right here.
That's correct.
Okay, so magnesium lives in the 3s position.
That's correct.
So I'm going to work backwards. I know I'm going to end with 3s, so I'm just going to start there, 3s. Okay, and if I look back at my periodic table, magnesium is in the 1, 2, the second spot of magnesium. So there's going to be 2 electrons in there. Now what I'm going to do is I'm just going to put in everything that comes before 3s. I know before 3s we have 2p, 2s, and 1s. And I'm just going to fill them up.
That's correct. That's good. So you're working backwards. I like the backwards. Notice how Mr. Sams is filling those, the one at a time before he doubles up.
Okay, so then my electron configuration I know is going to end with 3s2 because I'm working backwards. 3s2. That's my last thing that I filled. So I'm just going to put it in everything prior to that.
There you go.
Completely full. So I like to work backwards, less thinking involved.
I agree. Yeah, no, you're right. So if you can work backwards, that's always a bonus. All right, let's do some harder ones, and we'll work backwards. So which ones should we pick? Let's jump to something ugly. Let's do cobalt.
Ooh. That's not too ugly.
It's not too ugly. We'll get some ugly one here.
Yeah.
That's element number 27. So let's use the Samsian method.
All right.
The Samsian method.
Samsian electron configuratory method. I like it. Think I can get famous and get in a textbook?
I think so. Cobalt right here. That's where cobalt is on the periodic table. Now he's in the 3D. How many over is he? 1, 2, 3, 4, 5, 6, 7.
It's actually
7.
Yeah, it is 7.
I'm
okay,
right.
You're right.
So he's going to end. All right. That's not very good. But oh well. That's the 3D level, and it's going to be 7. So 1, 2, 3, 4, 5, 6, 7.
Notice Mr. Bergman made the down arrows before the up arrows. It doesn't matter.
Yeah, and
which one.
Also I'm doing the shortcut arrows just without the little ticky part because I'm lazy. Okay, so that's the 3D level, and so if we go back to our periodic table, that we did the 3D, we're going to go backwards. 4s, 3p, 3s, 2p, 2s, 1s.
So everything before 3D we put in.
So
4s.
I'm going backwards. You've got that page before you. 4s, and then what?
3p.
3p. And then
3s.
3s.
2p.
Trying to fit them all in right here. I don't know if I'll make it. 2p.
2s. 1s.
2s, and then we'll kind of put the 1s over here. And then everybody else is filled.
Fold.
Is it fold?
Sorry.
Are you being fooled?
I have small children. They're rubbing off on me.
I see that, yeah.
Okay, I need to brag on my son real quick.
Yeah.
I went on a hike last week with my family. My wife and I carried our twins on our backs. 11 miles on this hike, up from 9,000 feet to 11,500 feet up to this lake. We carried our girls, and that's cool. But my son, my 5-year-old son, hiked all the way up and all the way back 11 miles. He's amazing.
He's a rocket, man. I mean,
hiking
it's like he's gonna be a triathlete or something.
Could be.
Yeah. So, folks, that is the electron configuration. It's like, oh my gosh, it's getting longer.
Yeah.
Well, you know, there's 27 electrons. We've got to describe where each of them is.
Yeah.
What is their address? Each of them has its own particular address, and that's kind of the deal.
Should we show them the shortcut?
Yeah, let's show them the shortcut.
The shortcut! You're probably thinking to yourself, why did you just waste 10 minutes of my life and then now you're going to show me the shortcut? We're big fans of learning the hard way.
Yeah, so the shortcut is what you do is you go back to the last noble gas. Mm-hmm. So if you look here, we had cobalt. Where was cobalt? Is this the cobalt?
3p7, yeah.
I know. I'm trying to find it. I wrote it down somewhere. Here
it is.
So cobalt right here is on the 4th period. And so if I go back to the 3rd period, the last element on the 3rd period, which is right here.
That's argon.
And this is argon. You can do a shortcut, basically, because these electrons, the only electrons that really do anything in an atom are the ones on the outside. And that would be these electrons here. And so you only really need to describe these electrons, and all these other electrons can be described.
Everything up through 3p6, where argon lives.
Yeah.
We're gonna summarize or condense.
Basically, all of this right here. This is the electron configuration of argon. So you go and you write bracket argon, and then you just write
everything else.
4s2, 3d7.
Woo!
Done. That is the same thing as writing this.
All right, let's do one really big, hairy, ugly one. We'll do it the long way, then we'll do the shortcut, and then we'll be done.
Yeah, I think it's what I was thinking too.
Let's do
something in the F column.
How about in the F column or passes through the F column?
It's in. I don't care.
Let's do Mercury.
Mercury. Okay, let's do
HG, Mercury.
And Mercury has
80.
80 electrons.
80 electrons.
80. Okay.
All right. So
Mercury is it 6?
It's in 6.
So here is Mercury, right?
No, that's 7. Oh, it's in row 6. Sorry, not in 60. There.
G. Okay, so there's Mercury, and so let's go backwards.
Okay.
But I'm going to work backwards on a long sheet of paper, so to speak. Okay, so if we go backwards to Mercury, actually backwards, he's going to be 6 or 5D. It's 5D.
5D10.
It's the very last one, so it has to be a 10.
Yep.
So I'm going to do the 5D column. I'm going to make it way down here. 1, 2, 3, 4, 5D10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 5D column.
All
now
right,
we're just going to go
5D,
before 5D comes
6S.
No, it's the F, isn't it?
Oh, the F. You're right. Sorry, 4F.
Big long thing here.
There. Perfect.
There we go. So this is the 4F, and it's going to be filled. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
And before 4F is 6S. Just one box.
6S.
Full.
And then we're going to say the 5P.
5P, yep.
That's going to be a 3-boxer, right? 1, 2, 3, 4, 5, 6, 5P. And then 5, no.
Then 4D.
And then we got 4D.
Full.
Everything's full.
Everything's full up to the very last one. The last one's even full on this one.
The last one's even full too. And then what?
Then 5S.
5S. Okay.
Okay. Then 4P.
Now, folks, you know where Mr. Sams is getting that, right?
From the periodic table.
He's got the periodic table. It's this table. He just did 4P.
So the next is 3D.
So he's going to 3D, 4S, 3P, 3S, 2P, 2S, 1S.
Going backwards in order.
Just going backwards in order. So,
all right, 3D.
So 3D, so that's a bigger box, right?
Well, and it like comes out and like flies out at you, like you can almost touch it. Oh, that's a different kind of 3D. That was stupid. Don't ever let me say that again.
That was stupid, Mr. Sams.
I know.
And then I can say that's 4S.
3P.
And then we go back. Oh, hopefully I did this right. 3P.
3P. C3P. Oh.
That That's weak. Okay.
I've been watching a lot of Star Wars with my son lately. Oh, wait a minute. That's right. You're never mind. You're fine.
3s, and then we've got 2p. I'm doing this from memory because I don't have the periodic table thing in front of me, which you probably do, but I've done this a couple of times in my life.
Just a couple.
And then we have 2s, and then we last have 1s. Oh my gosh.
Oh wow, that's a lot of stuff. All right, electron configuration.
So 1s,
1s2,
2.
2s2.
That's just again here, and I see here
2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d6, 5p6, 6s2. No, 4d10. Sorry, my mistake.
Mr. Sams, I'm just listening to what you're saying.
I was just testing you to see if you're...
4d10, 5p6, 6s2,
4f14,
4f14,
5d10.
5d10. My word.
Okay.
Now, shortcut.
Shortcut.
I like shortcuts.
Yep.
So for the shortcut, Mercury is here, so we want to go to this element. He's in the noble gas, right? But the last guy in column number 5, and this
Xenon.
is xenon.
So we're going to take 5p6 and back, and we're going to
all of this
roll that into xenon
equals xenon. So we're just going to say brackets xenon,
and then everything after that. 6s2.
And then we're going to say 6s2 for f14. 5d10 done.
All right, so
all
that's
of
the
this
shortcut.
is equal to all of that.
Yeah.
We're trying to identify the location of every electron in an atom.
Yep, giving it an address.
Giving it an address. Okay, that's it, folks. You're going to get lots of practice in class, and if you're watching on the internet, your teacher will give you practice, I'm sure.
And if not, just pick an element and go.
Yeah. Talk to you later. Bye.